Welcome back. So let's wrap up this brief, very brief, and almost insultingly brief overview as to how bootstrapping works. So we had our real sample data from real people. We had 13 Brown and so on and so forth. We then took that real data and we made fake samples, bootstrap samples, using that very real data. You draw with replacement out of that real sample 20 times, right? We had 20 data points, so we do it 20 times. And that gives you one fake sample. And then with about 1,000, at least 1,000 fake samples, you can start building what will end up looking like a normal curve. We actually end up building a normal curve out of all of this. So that's pretty cool. And yeah, it's a normal distribution. And it's going to work out to be this normal distribution will be centered on the mean we got for our actual real sample. Because if 13 people have brown eyes, that's 65%. 13 out of 20 is 65%. Lo and behold, 65% corresponds to the peak and the center of this normal distribution. Now, this normal distribution is for our fake samples. It's for our fake data. And what is distributing is how you could get, using the same results you got and random chance, 20 people. And I did this a total of 1,125 times. And so for this being a normal distribution, I've got a mean. I could calculate a standard deviation, which means I can get a z-score. Once I've got a z-score, I can start finding the sample. I can start making population estimators, right? I can get a critical value. I can make a confidence level. I can do the equation. I can do all those things to come up with a population estimate. Or, if you want to be fancy about it, you don't have to do that directly, right? You got your confidence levels, which gives you some significance, some alpha over 2 as well. And if you're really hip to this sort of stuff, you can recognize that, right, the alpha over 2 is 0.05. So that's the bottom 5%. Well, we already have tools for finding the bottom 5%. That's the 5th percentile. The top 5% is the 95th percentile. And so you can use all of your fake data to quickly calculate your upper and lower bounds. So for instance, I got this backwards. Sue me. So lower first. So the lower bound, let's take alpha to be 0.1. So a 90% confidence interval gives me alpha of 0.1. So alpha over 2 is 0.05, 5%. So the bottom 5% would be, I need to type correctly, 0.45. And percentile of all this stuff, 0.95. That's the 95th percentile. It's giving me 0.8. So with a 90% confidence level, I can say that the true population proportion for brown-eyed people in Laverne is somewhere between 45% and 80%. If you want a lower confidence interval, that will, of course, move your intervals closer into each other. Your bounds will get closer and closer. If you want a higher confidence level, then the interval will be further spread apart. But that's all you have to do. So you could, once you've got your fake data, once you've got your normal distribution, you could find the mean, you could find the standard deviation, you could make a critical value with the z-score, you could do all the things we did in 7.1 or 7.2 or 7.3. Or, because you've got all this fake data, you've got all the values that make your normal curve, you could just do a lookup using percentiles. Either way. But that's how you get around not having a normal curve. So I'll leave this with you, as last slide. I'll leave this with you. Get a good sample size, get a good random sample, specify your confidence level, just like we've been doing, and make a good set of fake data.